Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Binti Mansor with student ID 2024256594 from the Bachelor of Surveying Science and Geometry, class RCFAP 2207D. This final year project was conducted under the supervision of Surveyor Zurahan Muhammad. Today, I will present my final year project entitled Assessment of Mangrove Species Composition under Different Salinity Profile in 2018 and 2024 at PULAU TUBA LANGKAWI, KEDAH, Malaysia. First of all, what is mangrove ecosystem? Mangrove ecosystem are coastal forests found in tropical and subtropical regions. They provide many important ecological services, including coastal protection, carbon storage, and habitats for marine organisms. One important environmental factor affecting mangrove is salinity. Different salinity level will create different environmental conditions, which influence where specific mangrove species can survive and grow. Therefore, understanding the relationship between salinity and mangrove species composition is essential for effective conservation and sustainable management. Next, I will explain about the background of study. Previous studies have shown that different salinity zones support different mangrove species. With the advancement of remote sensing technology, it is now possible to monitor mangrove ecosystem efficiently over large areas and across different years. In the study, I combined the Mangrove Vegetation Index, which is MVI, with the Random Forest Classifier to evaluate the changes in mangrove species composition between 2018 and 2024. Next, what is the problem in this research study? First of all, although salinity is one of the most important factors affecting mangrove ecosystem, continuous salinity monitoring is still limited. In Langkawi, human activities and environmental changes may alter salinity conditions, which can eventually affect mangrove species distribution. Without proper monitoring, changes in species composition may go unnoticed and could reduce biodiversity and ecosystem stability. This study addressed three research questions. First, which method is most effective for measuring salinity level across different mangrove zones? Second, how mangrove species composition changed over a 5-year period based on MVI and RF classifier? Third, what is the relationship between salinity level and mangrove species composition across different water zones? Next, I will explain about the aim and objective for this study. Aim is to analyze distribution of mangrove species composition across different salinity profile over a 5-year period. Objective: first, to measure salinity level across different mangrove zones using refractometer data. Second is to evaluate mangrove species composition using Mangrove Vegetation Index, which is MVI, and RF classifier over a 5-year period. And third, to determine the distribution of mangrove species composition with different salinity level over time. For the scope and limitation, this research was conducted at PULAU TUBA LANGKAWI, KEDAH, Malaysia. The study used Sentinel-2 satellite image together with field salinity measurement. Several software packages including Google Earth, Ardas Imaging, QGIS, and eCognition were used in the study. This is the full flow of work of methodology. So I will explain about phase 1 and phase 2. For phase 1, which is planning, it is categorized into 3, which is selection study area, selection software use, and also research problem identification. After that, for data acquisition, which is phase 2, it is categorized into 2, which is satellite image from Sentinel-2A, year 2018 and 2024, and also the measurement of field data from refractometer. After complete the phase 2, which is data acquisition, the objective 1 will be achieved. Next, I will explain about phase 3, phase 4, and phase 5, which is the final phase for this project. Firstly, Sentinel-2 satellite image were pre-processed through resample, layer set, subset, and geometric correction process. Next, field salinity data were collected using refractometer and interpolate to produce salinity profile maps. Then, the Mangrove Vegetation Index was generated, followed by mangrove species classification using random forest algorithm. Finally, accuracy assessment and spatial analysis were carried out to compare the result for 2018 and 2024 and to evaluate the relationship between the salinity and mangrove species composition. Next, I will proceed with the significance of study. This study contributes to mangrove conservation by improving our understanding of how salinity affects species composition. The findings can support environmental management, biodiversity conservation, and sustainable planning in Pulau Tuba, which is an important ecological and tourism area in Langkawi. Next, I will proceed with the result of the study. First of all is salinity profile result. The slide present the salinity profile map of the study area. The map shows that the salinity level vary across different parts of Pulau Tuba. This spatial difference provides the important information for analyzing how mangrove species are distributed under different salinity conditions. The second result is the comparison between MVI and RF classifier. This slide compares mangrove classification result produced using MVI and the random forest classifier for both 2018 and 2024. Overall, random forests provide a clearer separation between mangrove species and produce more consistent classification result compared to the MVI alone. This is the accuracy assessment of MVI and RF classifier. The accuracy assessment evaluates the reliability of both classification methods. This result shows that the random forest classifier achieved higher classification accuracy than the MVI approach, making it more suitable for the mapping mangrove species composition. This is the final result of the study. The final classification map illustrates the spatial distribution of mangrove species in both study years. Based on the classification of 2024 map, it reveals the changes in the spatial distribution of the classification compared to 2018 map. The classes were divided into four, such as mangrove, non-mangrove, built-up area, and water body. Based on the figures, it shows that the major difference between map of 2018 and 2024 is mangrove area. This is because the on 2024 map, the mangrove zone seems to be expanded to the nearby area until it affected the other classes. The figures show the accuracy assessment of mangrove composition classification of year 2018 and 2024. The classification accuracy was assessed using a confusion matrix. The confusion matrix compares the classified image and determines the producer accuracy, user's accuracy, and also overall accuracy. The statistical measures of the accuracy assessment provide the consistency of the classification result. This study successfully achieved its objective by analyzing mangrove species composition under different salinity levels in Pulau Tuba. The use of Sentinel-2A imagery, MVI, and random forest classifier produced reliable results. The comparison between 2018 and 2024 showed that salinity influenced mangrove species distribution over time. In conclusion, this study successfully achieved its objective by analyzing mangrove species composition under different salinity levels using remote sensing and machine learning techniques. Last but not least, future studies should use higher resolution satellite image, additional environmental data, and different classification methods to improve the mapping of accuracy, also support mangrove conservation and sustainable ecosystem management. That's all for me. Thank you.